Okay, welcome back, and today we're going to start Chapter 2, and Chapter 2 is all about graphs and functions. So in Section 1, we're going to talk about rectangular coordinates and graphs. So we're going to talk about ordered pairs, the rectangular coordinate system, the distance formula, the midpoint formula, equations in two variables. An ordered pair consists of components, two components, an x component and a y component, written inside parentheses. So if we look at these tables, we have a category and the amount spent. So we have to write an ordered pair that expresses the relationship between each category and the amount spent on that category. So we can write an ordered pair for food and $8,506. Or we can write an ordered pair that relates apparel and services with $2,076. Okay. So housing, we can use the second row and we can write the ordered pair housing $21,374. Okay, and this would be an ordered pair. Entertainment. Well, what would entertainment be? Well, that's going to be this one, so it's going to be the ordered pair that shows category followed by the amount spent. Okay. Now, the rectangular coordinate system, it was developed by René Descartes, famous mathematician and philosopher, by which we can locate any point in a grid if we know how many units in one direction and how many units going in the other direction if we look at two axes that are perpendicular to each other. Okay, so we have an x-axis and a y-axis, and so if we know what direction in the how many units in the y direction, and we know how many units in the x direction a certain point is located, then we can completely describe that location as an ordered pair of x comma y. And so also we can know what the quadrants are by the signs of x and y. So if both x and y coordinates are positive, we're going to be in the first quadrant. If the x is negative and y is positive, then we're going to be in quadrant 2. If they're both negative, quadrant 3. And if x is positive and y is negative, then we're going to be in quadrant 4. Now, using the coordinates of the ordered pairs, we can find the distance between any 2 points on the plane. So what we do is we look at horizontal side of a triangle has length, right? So we know that the distance here, right? So we know how do we get from this point to this point? Well, we know that there is a horizontal distance and there's a vertical distance that needs to go. And what happens is it forms a right triangle. Okay, so horizontal side of the triangle has length, and the d is distance of PQ. Okay, because or what sometimes you see a line segment, so it'd be PQ line segment. So it's the distance from P to Q. Okay, so the distance from P to Q is equal to the absolute value of 8 minus 4. Okay, why is that? Because it's a horizontal distance. It's in the x direction. So what's the difference in the x's? Okay, it's going to be this number minus this number, which is going to give you 12. And it's an absolute value because we're talking about distance. Okay. If you look at the vertical distance from P to Q, excuse me, PQ, right, going from, hold on a second. Oh, wait a minute. I'm sorry. This should be R. No, this should be QR or RQ. This one. Okay. So we're looking at the difference in the y values, right? So this is the difference in the y values. The 8's are the same. So the difference in the y values is telling us how far down it is. So we go this, the larger number, minus the smaller number, and so you get 5. Okay, and of course it's an absolute value. Now the Pythagorean theorem gives us the length of the remaining side of the triangle. And so we use a squared plus b squared equals c squared. Okay, and so we find that by taking the vertical or the horizontal distance squared plus the vertical distance squared, and then taking the square root of that. So we get 144 plus 25, and we get 169, which is square root of 169 is 13. So the vertical distance is, or excuse me, the distance between these 2 points is 13, for the length of the hypotenuse. Now, in general, to obtain the general formula, we just use x1 and y1 for point 1, so P. We use x2, y2 for this one, or excuse me, x1, y1, and we use x2, y2 for these 2 points. And then for this point here, we use x2, right, which is this one, and then y1. Okay, so now, by doing this, what do? We find that the distance formula is the distance between the distance in the x's squared plus the distance in the y's squared. Okay, and so this is the general formula for the finding the distance between 2 points, and we call it the distance formula. Okay, so you want to make sure you know the distance formula. So to find the distance between any 2 points, you take the x values, the corresponding x values, subtract them and square them. Then you take the subsequent corresponding y values, subtract them, square them. And then you add those 2 values and take the square root. So you're really just using the Pythagorean theorem. That's really all you're doing. So if we want to find the distance between those 2 points, then let's call this x1, y1, and call this x2, y2. Okay, and so now all we're going to do is plug in x2 and y2. So we're going to plug in 3 minus negative 8 squared. Okay, and then we're going to do y2. So this is going to be negative 2 minus 4 quantity squared. Okay. And we simplify. And we get 157. Square root of 157. Okay, and we're done. Now 157, I don't think there's a square root in there. Or, I'm sorry, perfect square. So we just leave it as the square root of 157. Do not put in your calculator. Just leave it as an exact answer. Now in this case here it says, if the sides A, B, and C of a triangle satisfy the Pythagorean theorem, a squared plus b squared equals c squared, then the triangle must be a right triangle with the legs having the lengths a and b, and the hypotenuse is c. Now, what we can do is we can use this to determine whether the given points are in fact the vertices of a right triangle or not. Okay, by just finding if it satisfies the Pythagorean theorem. So a triangle with 3 given points as vertices is a right triangle if the square of the length of the longest side equals the sum of the squares of the other 2 sides, the legs. So if we use this case here, so let's use M, N, and Q. So we can do Mn, so we can use the distance Mn, then we can use the distance Mq, we can use the distance Qn. Find all 3 of those distances. Okay, so let's do Mn. So the distance from M to N is given by this, right? Because we're using -2, 5, and 12, 3. So we use the distance formula, find out what that is, and we find that that distance is square root of 200. Okay. Now let's find the distance MQ. So let's find these two distances. So we're going to use these 2 points, and we're going to plug them in, right? And so we're going to then simplify and see what we get, and we get the square root of 400, which is equal to 20. Okay? Now we're going to do the last one. So NQ is equal to this, right? So we take NQ and we find the lengths of that side. Okay, now let's see if we get where it works. Let's find out. So we get this one, right? So both of these legs were the same. Okay, so this is an isosceles triangle. So this one is going to be 200. This is going to be 200. 200 plus 200 equals the 400, which is the length of the longest side, right? So this is 20 squared. So it is true, the triangle is a right triangle with the hypotenuse and joining M and Q. So M and Q is the hypotenuse. So this is a right triangle where this is the hypotenuse. And it's in fact an isosceles triangle. Now we can tell if 3 points are collinear, meaning that they lie on a straight line using a similar procedure. Okay, so keep this in mind. 3 points are collinear, again, meaning that they lie on a straight line. They all lie on a straight line. If the sum of the distances between 2 pairs of points is equal to the distance between the remaining pair of points. Okay, so let me say that again. So 3 points are collinear if the sum of the distances between 2 pairs of points is equal to the distance between the remaining pair of points. So let's look at this example here. So let's find the distance here. Okay, so we've got P, which is this point, Q, which is this point, and R, which is this point. And we want to determine whether they are collinear. So let's use PQ. So the distance PQ is given by taking these 2 points, and we find that the distance is 3 times the square root of 10. And then we do QR, and we find that that distance is 2 times the square root of 10. And then we find the distance between P and R, and we find that that distance is 5 times the square root of 10. So now, does the sum of 2 points, two pairs of points, distances, the sum of the distances between 2 pairs of points equal the distance of the last pair? And it's true. So in this case, we show that 3 points are indeed collinear. If it wasn't true, then they would not be collinear. Now, what about the midpoint formula? The midpoint formula is, well, what's the midpoint? The midpoint is the mid, if you were to connect 2 points with a line, the midpoint is the point on the line that connects 2 points that falls right smack dab in the middle of the 2 points. So how do we find the midpoint between 2 points? Well, we find the midpoint of the x's and we find the midpoint of the y's. In other words, we take the average of the x values and we take the average of the y values, and that's going to give us our midpoint. So we take the average of the two x values, and we take the average of the two y values. In other words, we're finding the midpoint here, right? And we're finding the midpoint of the y's. Okay, so now we want to find the midpoint M of the line segment with endpoints located at this point and at this point. So what we're going to do is we're going to use the midpoint formula. So we want to find the midpoint of the x's. So we're going to add 8 and -6, okay, which gives us what? 2. So divided by 2, so that's going to give us 1. Okay. And then we're going to add the y values, which is going to give us what? That's going to give us -3. So it's going to give us -3/2. And so the midpoint is located at 1, -3/2. So all we did was just find the midpoint of the x values, the midpoint of the y values. So this is just the midpoint formula. We take the two values and we find the midpoint between those two values. We just add them and divide by 2. Or in other words, take the average. So now we're going to find the coordinates of the other endpoint Q of a segment with one endpoint at -6, 12, and the midpoint is at 8, -2. So now we're going to use the midpoint formula, and we're going to say, hey, now we've got the midpoint, right? And we've got the other endpoint. So what they now want us to do is find the other endpoint. We want to find the point, the ordered pair that represents Q. So now what we're going to do is we're going to let x, y represent that point. And so we're going to use the midpoint formula twice. And here's how we're going to do it. We say x, right? So we're going to use the x value. So we say x plus -6 divided by 2 has to equal m, the x value for the midpoint. So that has to be equal to 8. Okay? So we're just using the midpoint formula for the x coordinate, which is going to be the x of one point. The other x value divided by 2 has to equal the x value of the midpoint. And then also, well, let's solve this one. So x is equal to 22. So now we're going to do the same thing for the y. So we're going to do y plus 12 divided by 2 has to equal -2. And so we solve, and we get y equals 16. So Q is 22, -16. And we're done. Now the following picture depicts how a graph might indicate the increase in the revenue generated by fast food restaurants in the United States from $69.8 billion in 1990 to $195.1 billion in 2014. Use the midpoint formula and the two given points to estimate the revenue from fast food restaurants in 2002 and compare it to the actual figure of 138.3. So, well, what 2 points are we interested in? Well, the midpoint, we're looking for the midpoint between what? 1990 and $69.8 billion and 2014 and $195.1 billion. So those are going to be our 2 points. We want to find the midpoint. So here's the graph, right? So here's our first point. So 1990, 69.8. So that's one ordered pair. And we've got this point, 195, 2014. So now we've got our 2 points. Now we want to find what's the midpoint between these two points. And so we're going to take these 2 points and we're going to use the midpoint formula. So we're going to take 1990 plus 2014 divided by 2, so the halfway point between 1990 and 2014, okay, which is going to be what? 2002, right? And then we're going to take the midpoint of these two. So we're going to add these two and divide by 2. And we get 2002, $132.5 billion. Now let's compare that to the actual value of 2002, which was 138.3, which turns out to be less than the actual figure. Okay, so the midpoint was actually less than what the actual value was. Now, for each equation here, now we're going to look at, we want to find at least 3 ordered pairs that are solutions. Okay, well, easy. I mean, there's many solutions, but all you have to do is first plug in a value for x and figure out what the corresponding value of y has to be. So if I plug in 0 here, then what am I going to get? I'm going to get -1 for y. So one solution is 0, -1. But what if I use 1 in here? Well, then I get 1 times 4 is 4, minus 1, which is 3. So I get a solution point of 1, 3. So literally, all you have to do is plug in a value for x and see what you get for y, and you're done. So there are many different values you can get, many different answers you can get. Okay. So we let x equal -2, multiply, we get -9. Y, so we end up with, right? So in this case, we let y equal 3. So you could also plug in for y and see what you get for x. So x equals 1. Okay, so this gives the ordered pairs -2, 9, and 1, 3. And we also that the ordered pair 0, -1 is also a solution. So there's 3 solutions. Those are not the only 3, but they are 3 solution points. Okay, now what about this? Okay, well, we have x equals the square root of y minus 1. Okay, so here's our equation. We plug in 1, right? Now, what do? We square both sides, but we still get 1 equals y minus 1. And then we add 1 to both sides, and we get y equals 2. So we have one pair, a solution, which is 1, 2. And then we can also verify that we want that one, 0, 1, and 2, 5 are also solutions. And there are others. So a table provides an organized method for determining ordered pairs. So we can create an XY table. So if we wanted to find solutions to y equals x squared minus 4, then we can just use a table of x values and find out what the corresponding y values are. So we can plug in all these values of x and then list out the values of y that correspond to them. And here is the table of solutions. And so we can write them as ordered pairs. So now what about graphing an equation by plotting points? Well, it's very simple and straightforward. So step 1, find the intercepts. Okay, you can always find the x and y intercepts, okay, by setting either x equal to 0 or y equal to 0. Then step 2, find as many additional ordered pairs as needed. Okay, if it's a straight line, you only need 2 points. If it's a curved line, then probably you're going to need more. Okay, 3 or 4, depending on the curve. Okay, 3, plot the ordered pairs from steps 1 and 2 on the rectangular coordinate plane. And then join the points from step 3 with a smooth line or curve. So let's graph this one. Okay, now this is a linear function, okay, or a linear line. So this is, notice this right here is linear. So it's going to be a straight line. So if we plug in values of x, right, so let's get some ordered pairs. Let's get the x and y intercepts, right? So the y-intercept is when x is equal to 0. So that means it's going to be -1. So the y-intercept is 0, -1. And when this is 0, what do we get? We get 1/4. Okay, so we get the the x-intercept of what? X equal 1/4 comma 0. Okay, so there's the x-intercept, and so the intercepts are going to be negative or not negative 1/4 comma 0 and 0 comma negative 1. Okay, and we found some other ordered pairs that we found also in example 7a. Okay, right? These are the ones that we did in this is the same example that we did before, where we found those other ordered pairs. Now, you don't need to have 5, 6 different ordered pairs. Okay, so they give us ordered pairs of -2, -9, and 1 comma 3. And so now, if we graph these, we're going to plot the 4 ordered pairs onto the rectangular coordinate plane. And then we're going to join these with a nice smooth curve. Okay, and notice it is a straight line. So you only really need 2 points to plot a straight line. So notice that we have the intercepts, okay, and then we've got these 2 other additional points that were found. Now what about this one? Let's graph this one. So this is the other one that we were looking at. So let's graph this one. Okay. So if we graph this one with the points that we had obtained, again, we can find the x and y intercept, right? So the x-intercept is when y is equal to 0. So that's going to give us -1, which square root of -1, which is not a real answer. So guess what? This does not have an x-intercept. Okay. But if we set x equal to 0, then what happens? Y is equal to 1. Okay, so we have we have a y-intercept right here. Okay, and then we plot some additional points to give us an idea of what the curve looks like, and then we plot the curve with a smooth line. Okay, now what about this one here? So again, we can use the table of values and just start plugging in values of x from, let's say, 2 to -2 or 3 to -3 to get an idea of what the y values are doing. And then we can plot those y values and sketch the curve of a parabola, right? So this is a quadratic, right? So this is a quadratic equation or a function. So this is going to give us a parabola. Okay, so that is the end of our first section. So again, please make sure you're keeping up the videos. If you are confused, you may watch them again. Of course, watch them at your leisure. Practice using the examples and practice the suggested homework problems. If you get stuck on anything, you don't understand something in this video, please reach out to me for help. Ask me questions. I will be more than happy to answer your questions in class. If you want to email me and say, hey, can you go over this one in class, I'll be more than happy to. Okay? Until then, have a great day.